Hello everyone. This is part 3 of the chapter redox reactions, and in the previous two parts I have discussed that there are two ways of balancing redox reactions, right? The first way I have discussed already and two videos are already posted, which is half reaction method, and this method is also called as ion electron method. So two videos have already been posted, and the videos will tell you both the ways, that is, if you are getting an equation, how can you balance it in the acidic medium, and how the same equation can be balanced in the basic medium. Now today I am going to discuss the second method of redox reaction balancing, and this is called as the oxidation number method. So as you already are aware, if you have seen the previous two videos, that there are few steps that we have to follow so that we can balance a given redox reaction. So in this oxidation method, again we have got few steps. So let us first of all write down the steps involved in it. The first is to find out the oxidation number of every atom that is given to us in the equation. The second is then to see the case where oxidation number increases and the case where oxidation number decreases. Point to be noted: when oxidation number increases, it is said to be undergoing oxidation, and when the oxidation number decreases, it is said to be undergoing reduction. So we will find that in the third step we are going to do the crisscross. Now what is that crisscross? Remember one thing, this crisscross will be done only on the left hand side. We are not going to do it on the right hand side of the equation. Now what do we mean by crisscross? Now in the second step we find that something will undergo oxidation and something will undergo reduction. Now suppose this is X and it has undergone oxidation. So we will write the number of reduction over here, okay? And suppose this is Y which has undergone reduction, but we will write the number of oxidation over here, right? You will understand what does that mean. In the fourth step then, we will balance every other atom except oxygen and hydrogen. We will not balance oxygen and hydrogen. In the fifth, then we will balance oxygen. How to balance oxygen? Only by adding water, and water will be added to the side which is deficient in oxygen. Okay. Now the last step would be to balance hydrogen. And what is the way to balance hydrogen? That is by adding H positive ions to the side which is deficient in hydrogen. Is that clear? So we are going to follow these steps. Now before I start with the problem, I want you all to write these steps, and so that when we solve the equation you all know that. Okay, so total how many steps are there? 6. So now let us take one example. I am writing the equation. So the equation is MnO4 negative plus Fe2 positive. It will give us Mn2 positive plus Fe3 positive. Okay, so you will write the steps and we all will see that we will follow all the 6 steps and we'll get the answer. So the first step is to find the oxidation number of each. Now in this particular case we are confident with oxygen. We will assume manganese to be X. So let us all start. X plus total 4 oxygen minus 2 is the oxidation number of 1 oxygen, and it is equal to minus 1 because the charge over here is minus 1. So it will be X minus 8 is equal to minus 1, X is equal to minus 1 plus 8, and X is equal to plus 7. So we got the charge oxidation number. So we have written it over here. Now this is only iron in the ionic form, that is ferrous. So when we have got just one, the charge is equal to the oxidation number plus 2. Now this is also manganese in the ionic form. So charge is equal to the oxidation number plus 2. And in the last we have got iron again, but in the oxidation state plus 3. So the charge will be equal to the oxidation number. So we have found our step number 1 in all the atoms which are involved. So we are done with our step number 1. Okay. Now step number 2 says that find out where the oxidation number is increasing and where is it decreasing. Now if you see carefully, manganese on the reactant side is plus 7 and in the product side it is plus 2. So obviously the oxidation number decreases, and since the oxidation number has decreased, it means it is undergoing reduction. And what is the change in the number? So from plus 7 to plus 4, it means the reduction is by 5. We have written that number also. Now one thing to pay attention whenever, and this is very very important and we may do some mistake if we do not follow the steps properly, reduction and oxidation is for one atom at a time. So over here if you see manganese is 1, so it means that 5 is okay. We are writing 5, that the reduction or the decrease in the oxidation number is by 5. Suppose that it was Mn2, right? Then we were supposed to multiply it by 2. If it was 3, we were supposed to multiply it by 3, 4 multiply by 4 and so on. So over here we need to pay attention to the reactant side, that how many atoms are given. If it is 1 like right now, we will just write the decrease, how much the decrease is. So 5 is okay over here. Now let us move to iron. It is oxygen. It is minus 2 and we don't have oxygen, so we need not pay attention to it. Fe is plus 2 and here if it is plus 3. So it means that the oxidation number has increased. So increase in the oxidation number means that Fe2 positive is undergoing oxidation. And by how much? Plus 2 is changing into plus 3. So oxidation is by 1. And again, just see how many atom? 1. So it means that the number 1 that we have written is correct. Suppose it was Fe2, then we were supposed to multiply it by 2. 3, then 3, 4, then 4 and so on. The same concept. Okay. So now we are done with step number 2 over here. Keep on checking the steps also so that you get to know that whatever we are doing is as per the steps that we have already written. Okay. So we have found the reduction and the oxidation. Now let us move to the step number 3. Now I request that when we move on to the step number 3, we write the equation once again. Why we write the equation once again? Because already we have done so many things on the previous equation that if we will write it on the same, it may create confusion. So I have written the same number. Now have a look that MnO4 is undergoing oxidation. Now third step is the crisscross. Why crisscross? This is undergoing reduction. So I will write the number of oxidation in front of it. And this crisscross will only be done on the left hand side but not on the right hand side. Okay. So I am writing 1 over here. I hope that we are clear that why have I written 1? It has undergone reduction, but we are supposed to write the oxidation number in front of it. The same. Now this is undergoing oxidation, but we are supposed to write the number of reduction in front of it, and I will write 5. I hope this step is clear, right? So we have done the crisscross. Now we move on to the fourth step, and fourth step says that balance every other atom except oxygen and hydrogen. So we will balance every other atom now. So I have got 1 manganese. Here I have 1 manganese. That is already balanced. Here I have got 5 Fe, but here I've got just 1. So I need to make it 5 and I am adding 5 over here. So my every other atom is balanced, and you can see that right now I have not paid attention to oxygen because we are at step number 4. So by the end of step number 4, this is the change in the equation, right? Now, moving on to step number 5, now we are supposed to balance oxygen. And how to balance oxygen? By adding water to the side which is deficient in oxygen, राइट तो मतलब जिस साइड पे ऑक्सीजन कम है उस साइड पे हमको क्या ऐड करना पड़ेगा? वाटर. ऑक्सीजन को बैलेंस करने का बस यही एक फॉर्मूला है जो हमें अप्लाई करना है. ओके, सो ओवर हियर आई हैव गॉट 4 ऑक्सीजन, but on this side there is no oxygen. So can I say that this side is deficient in oxygen? Yes, this side is deficient in oxygen. And how to balance oxygen? By adding water to that side. Now over here there are 4 oxygen, but here I have just 1. So how can I make it 4? By adding 4 water molecules, right? So now if you see, my manganese is balanced, oxygen is balanced, iron is balanced. But when I add water to the product side, I get 4 hydrogen molecules also, right? So I have to move to the last step now, that now I have to balance this hydrogen by adding H positive ions to the side that is deficient in hydrogen. Now if you see carefully, this side has got 8 hydrogen, but here I don't have any hydrogen. So how many hydrogen will I add over here? That is 8. And what is the way to balance hydrogen? By adding H positive. So I will add 8 H positive ions here. Okay, and now this is the final equation that we get. I am rubbing out all the other steps so that we all can see the equation. And let me just write the equation once again. So we get MnO4 negative plus 5Fe2 positive plus 8H positive. It will give us Mn2 positive plus 5Fe3 positive plus 4H2O. Now this is the equation which is for the acidic medium. Okay, now suppose the equation was given and it was written in the bracket that balance this redox reaction by oxidation number method in acidic medium. So the steps that we have followed till here is for the acidic medium. But suppose that the same equation is asked to be balanced in the basic medium. So how are we going to do it in the basic medium? For the basic medium, there is only one step extra, and that step is to add OH negative ions. Okay, now how can we add OH negative and how much do we need to add it? How are we going to decide? So you all can see that in this equation on the reactant side we are getting 8H positive. Now suppose we are asked that we have to write this equation in the basic medium. So just see that how much H positive do we have? We have got 8H positive. So we need to add 8 OH negative to both the sides. Okay, so we'll add 8 OH negative on the reactant side and 8 OH negative to the product side. So let us see that what is the equation that we will get. MnO4 negative plus 5Fe2 positive plus 8H positive plus 8 OH negative. It will give Mn2 positive plus 5Fe3 positive plus 4H2O and 8 OH negative. Okay, don't forget to add OH negative equal number on both the side. Now what is the twist? That this 8H positive and 8 OH negative, it becomes 8H2O. Okay, H positive and OH negative makes water only. And if you see carefully, we have got 4H2O on the product side also. And if we have got same molecule on the reactant side and the product side, they get cancelled. So this 4H2O will be cancelled, and out of 8 molecule of water we are left only with 4. So now is the time to write the final equation, and the final equation becomes MnO4 negative plus 5Fe2 positive plus 4H2O. It will give Mn2 positive plus 5Fe3 positive plus 8 OH negative. And this equation that I have written with green, it is the same reaction but which is balanced in the basic medium, right? So what we have understood, that is same reaction can be balanced in the acidic medium, and that acidic reaction medium can be changed into basic medium by just adding OH negative ions, right? I hope you have understood from the video. I am giving you one homework and I will discuss it in the next video then. So you will try and do it and you will wait for the next video, that is I2 plus HNO3. It gives HiO3 plus NO2 plus H2O. Try and solve this in by using oxidation number method. So thank you everybody.